This problem is of planetary motion, that is from central orbit, and the problem is if omega be the angular velocity of the planet at the nearer end of the major axis, prove that its period is given by 2 pi by omega into 1 plus e by 1 minus e whole cube whole to the power 1/3, where e be the eccentricity of the orbit, that is eccentricity of the elliptic orbit, because we know that from the Kepler's law orbit of a planet is elliptic, right? Now we draw a rough sketch of the orbit, that is of the elliptic orbit, as like this. This is the orbit, and let it be the position of S or sun, and this is one of the focus, and the planet at the nearer or nearest end of the major axis, that is the planet at A. Here be the planet and here be the sun. So the radius vector r, this is equal to SA, and if this ellipse is given by x square by a square plus y square by b square, this is equal to 1, then e square, this is equal to 1 minus b square by a square. Okay, now we know that the radius vector r, this is equal to SA. This means this is OA minus OS, and this is given by A minus OS. OS means the coordinate of S is AE, 0. If this is the origin and this is taken as y-axis, this is taken as x-axis, right? So OS, this is equal to A and A into 1 minus E. This is the length of the radius vector, and here it is given that omega be the angular velocity. So theta dot, this is equal to omega. It is also given because if this is the radius vector and this angle is theta, then angular velocity theta dot, this is equal to omega. Now in central orbit we know that r square theta dot, this is equal to h, and this is a constant, and we know that this relation h, this is equal to root mu into L, that is root mu into semi-lattice rectum, or this is equal to mu into semi-lattice rectum means b square by a for the elliptic orbit. Okay, so we put here this is equal to root mu into b square by a. Now we put theta dot, this is equal to omega from this relation, and r, this is equal to a into 1 minus e from this relation. We get a square into 1 minus e whole square, this into omega, because theta dot equal to omega, and this is equal to root mu into, here from this relation if we calculate b square, we get a square into 1 minus e square. So we put here a square into 1 minus e square by a, and this is given by root mu into a into 1 minus e square. Okay, so this relation gives root mu, this is equal to a square into 1 minus e whole square into omega by root a into root 1 minus e square, right? And from the Kepler's law, we get the period in planetary motion or period in elliptic orbit, we get period in elliptic orbit is T, which is given by 2 pi by root mu into a to the power 3 by 2. Right? This relation is known from Kepler's law of planetary motion. And we put the value of root mu here. We get 2 pi by, this is given by a square into 1 minus e whole square into omega by root a into root under 1 minus e into 1 plus e, right, into a to the power 3 by 2. Now by calculating we get, this is 2 pi by omega here, 2 pi by omega, and we cancel out a square and root a. This gives a to the power 3 by 2 and a to the power 3 by 2 whole cancel. So this and this cancel out. Now the result is here 1 plus e root by, this is 1 minus e whole square, 1 minus e whole square minus half. So this is given by 2 pi by omega into 1 plus e by 1 minus e whole cube to the power half, and this is our required result. Right? This is the periodic type we prove here of the elliptic orbit. This is the solution of this problem. Thank you for watching.